So this will be our third and last day talking about 10.2 Cartesian equations for conic sections. Let's see, so I'm going to just keep using my exact same notes, and we're going to continue on to example 6. Oh, and maybe I'll put a little day 3 here. Actually, I'll write day 3. Okay, so the problem is that we need to transform we've got a conic section here, x minus 2 over 5 squared plus y minus 4 over 3 squared equals 1. Okay, so just by looking at this, and potentially your notes if you don't have this memorized yet, I'm seeing that my coefficients are different, right? I've got 1/5 or 1/25 if I take it out of the squared, and 1/3 or 1/9 if I take it out of the squared. So my coefficients are different. Both terms are positive, however. So if I look at that, coefficients being different, but both terms being positive, that tells me that it's an ellipse. Okay. If the terms had been one of them negative, so opposite signs, it would have been a hyperbola. Okay, so I know it's an ellipse. All right, I'm going to transform this into ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And this is basically all the a, b, c, d, e, and f. Those are all constants. So where a, b, c, d, e, f are constants. Okay, so in order to do this, I'm just basically going to do a whole bunch of multiplication and then combining like terms. So first thing I'm going to do is I'm going to get rid of the squares. So I'm basically going to square each of these terms. Okay, so I'm going to have, instead of x minus, well, here, I'll write it out. So this really becomes x minus 2 squared over 25. Plus, and then this is y minus 4 squared over 9. Okay. Now, a couple ways to do this, and I'm going to do two things at one time. First of all, I'm going to multiply this out. This is not x squared plus 4. If you think that this is x squared plus 4, very bad, okay? So I'm going to multiply that out, okay? I'm going to get a trinomial from that, because remember, there's inners and outers. Same thing here. And at the same time, I'm going to clear my fractions. So in order to clear my fractions, I basically want to multiply by these two denominators. So I'm going to multiply both sides by 25 and by 9. Now, I haven't written out, I mean, I know that 25 times 9 is 225 because I've already done this problem before. I haven't written it out necessarily because when I distribute, only certain, like one of these is going to reduce. So for example, when I distribute this to the first term, the 25s are going to reduce. When I distribute this to the second term, the 9s are going to reduce. Okay, so I don't want to multiply it out just so I can divide it back up. So let's go ahead and multiply then. So I'm going to take x minus 2 and square that, which is going to give me x squared minus 4x plus 4. If I distribute this 25 times 9 to this first term, the 25's reduce, so I'm still left with a 9. So this is 9 times all that stuff. Plus, okay, now let me go ahead and double distribute or FOIL the y minus 4. So it's basically y squared minus 8y plus 16. And again, if I take this 25 times 9 and distribute it over here, the 9's are going to reduce, and I'm going to be left with a 25. So there's 25 being multiplied to all of that. equals, and I said that this was going to be, what did I say, 225. Okay, from there I'm going to go through and distribute now. So I've got 9x squared minus 36x plus 36 plus 25y squared minus 200y plus 400 equals 225. Let's see, well, we can combine any like terms that we might have. So we should have 9x squared. I don't see any other 9x or any other x squared. So 9x squared. Took care of that one. And they wanted to go x squared. Oops, did I get these all? Yep, okay, so then bxy. Do I have any xy terms? No. Let's see, we want our next one to be the y squared term, so that's going to be 25y squared. Okay, that's taken care of. Next is going to be something x, so I've just got the negative 36x. Next is going to be the single y term, and I think I just have the negative 200y. And next is going to be our constant. Okay, so let's see. On this side, I've got 436. So I'm going to go ahead and write that out. And then I'm left with 225 over there. But notice for our standard form here, we wanted it to be equal to 0, which means now I need to subtract that 225 over, and that'll give me 211. And I'll just rewrite everything else. And that is completely expanded. Oops, why do I have 0, 0? All you need is 0 there. All right, so if I was just looking at this form now, so we talked about why looking at this form I knew it was an ellipse. What if I was just looking at this form, how would I know it's an ellipse? Well, the reason that you know it's an ellipse is because your two x squared and y squared terms, they're both positive, but they have different coefficients. So therefore you know that it's an ellipse, okay? Also notice how you have no xy term here. If you had an xy term, that would mean that it would actually rotate this figure. But don't worry about that right now. We'll go over that in 10.6. Okay, so we call this right here, this is standard form. So we wrote it in standard form. And again, just looking at it in the standard form, we know that this is an ellipse because the two coefficients of your two leading terms, the x squared and the y squared, they're different, but they're both positive. Just like over here, coefficients are different, but they're both the same sign. Okay, moving on, we're going to do a little bit of review from Algebra 2. Well, actually, probably even from Algebra 1. But you may not remember it so much. So we're going to talk about completing the square. So recall completing the square. I'm going to do two examples of completing the square. So one of them was to solve by completing the square. So how about we go with x squared plus 4x minus 12 equals 0. So completing the square is just another way of getting this thing to basically be a binomial squared, so that way I can take the square root of both sides and solve it. It's just another way of solving this thing. You could also, could you factor this? 6 and 2? Yeah, I think you could totally factor this, okay? So using a simple example to show you completing the square, This is used actually in the derivation of the quadratic formula. We did this last year in Algebra 2. We derived the quadratic formula. Not going to do that for you today. So the first thing you do when you have a trinomial set equal to 0 and you want to solve by completing the square, you're going to take your constant, you're going to move it to the other side so that you just have your x squared term and your x term on one side. So the first thing I'm going to do is add 12 to both sides. Okay, now the next thing I'm going to do is I'm going to add b over 2 squared. Okay, so right here, I now add the b over 2 squared. And I'm going to do that to both sides, right? Because if I do it on one side, I got to do it on the other side. Well, my b here is 4, right? And in case if you forgot, a would also be 1. And I think c would be negative 12. Okay. That would be in your original. So here we've got b is 4. All right, so I'm going to go ahead and add 4 over 2, which is 2, squared. I'm just going to write it as 2 squared. I'm going to do that to both sides. Over here, I'm going to go ahead and write it as 4. Now, the reason I do this, okay, and maybe I should write it over here. So b over 2 squared is the same as 4 over 2 squared in our scenario here. Okay, and that's where the 4 divided by the 2, I got 2 there. So 2 squared. Now, the reason I write it like this is because this is basically a perfect square trinomial, which can be rewritten as a binomial squared. Okay, so this basically is the same thing as x plus 2 squared. So this is the same now. We are writing it as the square of a binomial. And if that vocabulary is hazy for you, you don't remember it, then go back and look at your factoring friends. Okay. And over on this side, I got 16. Now, this is a pretty simple problem now to solve, right? In order to get rid of that square, I can then square root both sides. So I'm left with x plus 2 equals positive or negative square root of 16. Or x plus 2 equals positive or negative 4. And so when I solve this, I get x equals, I'll subtract 2 from both sides, plus or minus 4. So I get x equals, well, negative 2 plus 4 is 2. And x equals negative 2 minus 4 is negative 6. So there's your two solutions. Yes, you could have factored this, but I'm reviewing how to solve using completing the square. So the main point of completing the square, you move the c over, you add b over 2 squared to both sides. You're then able to rewrite this trinomial, which is a perfect square trinomial, as a square of a binomial, which then allows you to take the square root of both sides, giving you your two x-intercepts. Now, that wasn't the only time that we used completing the square. Another time when we used completing the square was when we wanted to rewrite an equation in vertex form. I should say a quadratic equation. All right, so let's see. My equation here is y equals 3x squared minus 12x plus 1. Now, vertex form, those are on your parent graphs. Let's see. We've already been over this, but let me grab my parent graph here to show you guys. So, for a quadratic, your vertex form is where you have those transformations, the h and the k, and that gives you your vertex. So I'll go ahead and write that down because that's the form that we want to get this into. And what's nice about this is a great way to graph them, I think. It's probably my favorite way to graph quadratics because right away I know where the vertex is, which also gives me my axis of symmetry. And once I have that, I can just put in like one other point besides my vertex, usually my y-intercept, graph it, basically reflect it over the axis of symmetry. So it becomes a really easy way to graph. All right, so we're going to go ahead and rewrite this in vertex form. So the first thing I'm going to do is I'm going to group my a and b terms, okay, or my x squared and my x terms, because that right there, that's what I'm going to complete the square on, okay? So I leave that +1 out there. Now, the difference between this way of completing the square and this way of completing the square, notice this one's set equal to 0. So you're solving, you're looking for your x-intercepts. This one is a function in function form, and you still want it in function form when you're done. You are more than welcome to take this one, subtract it over here, and go ahead and complete the square on both sides. But it will get more complicated. So this is the better way when you're trying to rewrite this in vertex form. I would highly recommend that you follow what I'm doing here. Okay, so first thing I'm going to do in this part right here, I see that there's a common factor. You always want your a to equal 1. A does not equal 1 here. In our previous example, we didn't really have to worry about it. Our a equaled 1. However, if our a didn't equal 1, we would then divide both sides by that. Okay, so we'd move our 12 over, and then we divide by whatever over here. This isn't going to be so easy for us. We don't really get to do that because we've still got this 1 over here, and we don't want to work with all these crazy fractions. So instead what I do, I just factor out the greatest common factor, which a and b have a common factor of 3. So I'm factoring out a 3. And then I'm going to be left with x squared minus 4x. Now, in here I'm going to complete the square. So now I'm going to take my b, which is 4, and I'm going to divide it by 2 and square it. I'll go ahead and I'll write that out. So I've completed the square inside of here. Now on the outside, because I've added, basically I've added 4 here, right? This is 2 squared, so that's 4. But I haven't just added 4. Multiply it by 3, right? Because there's this 3 out here. I've really added 12. So on the same side of the equation now, I'm going to subtract 12. So let me go over that one more time. I completed the square by taking b, dividing it by 2, and squaring it. If you simplify this, this basically gives you 4. But I didn't really add 4 because this gets multiplied by this 3. So I really added 12. So on the same side of the equation, I'm going to subtract 12. Now, if that confuses you, you can actually add 12 over here. And then later on, you're going to have to come back and subtract it. Actually, that's going to pretty much be almost our next step. So it's really in your best interest to keep it looking like vertex form. Okay, so now this is really 2 squared. I'll write that out for you guys. And this is really, oops, negative 11. I'll subtract 11. Once again, I've got a perfect square trinomial. First term's a perfect square, last term's a perfect square. If I multiply them and double them, I'm going to get this. Okay, so I can rewrite it as the square of a binomial. So keeping the 3, this is going to be x minus 2 squared minus 11. So now if I had to graph this, my vertex is at 2, negative 11. And it's a parabola. Okay, so let's see our next example. We're going to transform the equation. This is our last example, and then we'll be done. Example 7. Transform the equation. This time they're going to give it to you in that standard form. 9x squared minus 4y squared plus 90x minus 32y plus 197 equals 0. And they want you to put it back into center radius form. By completing the square. Okay, so just looking at standard form, my coefficients are different, my signs are different of my leading terms. So right away I should know that this is a hyperbola. Okay, so just thinking about that as you're actually doing this. Now, if I put it into center radius form, let's see where did I put my note. I want it to basically look like this and be set equal to 1, right? And I think our x squared is positive and our y squared is negative. So yeah, it'll look very much like this one, where our y squared is the negative term. Okay, so the first thing I'm going to do is I'm going to group my x's and my y's together. So I'm going to move some things around, bring that 90x over here. So I'm going to have 9x squared plus 90x. And then I'm going to have the minus 4y squared minus 32y. And then I'll set that equal to negative 197. So I just move the 197 over to the other side. So I'm grouping these guys together. I'm going to keep that negative with the 4y squared because it belongs with the 4y squared. So I'm going to put like a little plus sign in between. And adding a negative is the same as subtracting a positive. So it works out. All right. Now what I'm going to do is I'm going to factor out the greatest common factor here so that I end up with a being 1. Okay, and I'm going to do the same thing over here. I want my a to equal 1. Okay, so I'm going to have 9 times x squared plus 10x. And I'm going to leave some space there because I'm going to have to complete the square. So what I'm going to, I think I'll come back to that. I'll do that in a second. I'll just leave a little blank there. Over here, I'm going to subtract or factor out a negative 4, leaving me with y squared plus 8y. And then I'll leave myself a little blank right there for a moment so I figure out what I'm doing. And then equals negative 197. Okay, so this is my b in my first grouping. So that's 10 divided by 2 is 5. So I'm basically adding in 5 squared here. And then the same thing here, my b is 8. So 8 divided by 2 is 4. So I'm adding in a 4 squared here. Okay, so what have I just done? I've added actually 25 times 9, right? So I've added, was that 225? I've added 225, so I need to do that to the other side. And then I'm going to do the same thing here. Let's see, so that's 16, but times a negative 4 is a negative 64. So I've subtracted 64 from this side, so I need to subtract 64 from the other side. I'm out of room, so I'm just kind of going down. Now I'm going to write each of these two terms, right, this first term and the second term, as 9 times a binomial squared, or a square of a binomial. So this is really going to be, let's see, I'll go down a little bit, 9 times x plus 5, quantity squared, minus 4, do the same thing, make this a square of a binomial, y plus 4 squared, equals, and when you combine all these things, you should get negative 36. Okay, I'm almost there, but not quite. So, I've got both of these now squared, but I don't have my dilation factors for x and y, and I also don't have this over here set equal to 1. So, let's do that. I'm going to need to divide both sides by negative 36 in order to make that happen. Okay, so I'm going to take 9 over x plus 5 squared and divide that by negative 36. And then I'm also going to take that negative 4 times the quantity y plus 4 squared, divide that by negative 36, and that's going to end up leaving me with a positive 1. So now simplifying, 9 goes into 36 4 times, and now this whole term has become negative. So it's really a negative x plus 5 squared over 4. And this whole term becomes positive, and this reduces to 9. So plus, and we're going to have y plus 4 squared over 9 equals 1. Okay, and then the last thing I want to do is I want to make these as squared terms, right? So I want to make these as the whole thing being squared. So I'm going to have negative x plus 5. Oops, let me put my parentheses around the whole thing. Over 2 squared plus, and then same thing here, this is y plus 4 over 3 squared equals 1. And I think we are done. We have transformed that into center radius form.